Healthcare and WSC Symposium this year. My name is Wei Lu. Currently, I am running a startup company named K2Data, which provides big data and AI services to industrial companies. Before I found K2Data, I was a researcher working for IBM. The topic I will share today is about the digital transformation of industrial companies in China. This is what my company is working on. Besides, I will also introduce my company K2Data a little bit and share some important lessons I learned during my journey of a startup company CEO who once only had experiences of doing research. Let me start from why digital transformation is essential for industrial companies in China now and share several use cases with it. First, the digital transformation is not just unique to China. It's a natural choice for industrial companies during the fourth industrial revolution, which is happening worldwide. If the label of the first industrial revolution is mechanization, the second one is electrification, the third is automation plus informatization. Digitalization is then the label for the fourth industrial revolution. In the past 20 years, industrial companies in China have invested a lot in building automation and information systems. Now there are systems like DCS, MES, ERP to manage the production and management process of factories. These systems generate lots of data, which form a good foundation for digitalization. There are also unique China market drivers. China is under a major paradigm shift from a low-cost production center to a country which can add more value in product design, customer services, and other segments of a product lifecycle than just the manufacturing. Even for manufacturing, China is striving to build competencies in advanced manufacturing so as to make fine and high-quality products. There are both external and internal drivers for this shift. On one hand, the cost advantage China used to have is diminishing. According to Boston Consulting Group's report, the total cost of running a factory in China and US is about the same now. So China has to change its role when low-cost manufacturing is moving to VLAN and other even lower-cost countries. On the other hand, when we look at China itself as a market, China is changing from a country of deficiency to abundance, so people begin to pursue high quality life. The end of low cost expansion urges companies to find new engine for growth, and digital transformation can empower the shift of growth drivers. Digital transformation means leveraging digital technology to improve competitiveness of enterprises and drive this model innovation so the enterprises can meet uncertain and personalized market needs and eventually achieve this growth. It empowers growth driver shift from low cost to innovation, in innovation in new product design, in new ways of engaging and serving customers, and also in optimizing business operations, mostly driven by data. Earlier this year, Chinese government announced the support for 7 types of new infrastructure, including artificial intelligence, industrial internet, 5G wireless, which is an accelerator for the digital transformation of industry companies. Now let's take a look at what specifically industry companies can do under digital transformation. This pyramid summarizes typical application scenarios. At the bottom of the pyramid is intelligent product and services. If we make every product connected and intelligent, new types of customer services can be provided to users, taking this connected product as a customer engaging channel. The second layer is about production process innovation with intelligent manufacturing equipment, production line, and factory. The third layer is about operation model innovation, typical use cases including intelligent product design, smart supply chain management. The top is how to enable smart decision making for the factories. Let me give 3 specific customer use cases for the bottom 3 layers. The first use case is connected services for engineering machinery with SDLG, a manufacturer of loaders and excavators, with sensors to connect working condition data of major components such as engine speed, hydraulic system pressure, together with operator actions with the machine and other data such as GPS location. Various kinds of data-driven services can be built. Typical examples including predictive maintenance so as to reduce machine downtime, spare parts prediction to reduce spare parts inventory, and sales prediction and targeted marketing based on workload profiling to understand the working condition of each machine and also understand the infrastructure construction market needs. Another use case is about product quality control with Steel, which is a major high-speed train rail manufacturer with over 50% of market share in China. In order to have the train move smoothly with a speed over 300 kilometers per hour, there is a very high standard with the train rail. For 100 meters long train rail, shape error should be smaller than 1 millimeter, so the rolling process should be controlled very carefully. Although the rolling mills are controlled by automation system, rolling process parameters are set by rolling workers when a work shift starts based on information such as product type, roller condition. There are over 300 process parameters including rolling pressure and roller gaps for each rolling mill. It takes about 10 minutes for very experienced workers to set all the parameters, while newcomers may take up to 45 minutes to do parameter setting. That costs a lot of time. And different settings may have different impact to roller lifetime. Even the product quality is about the same. By analyzing the process parameters and quality data of all past product batches, we developed a rolling process parameter recommendation system, which reduces work shift preparation time as well as extending roller lifespan. Besides, we also develop a fast defect root cause identification system by understanding deformation of the rails during the rolling process, so we can map data connected from each rolling mills to every meter along the rail, so as to accelerate the root cause analysis process. The third use case is about data-driven personalized product design with Goldwind, the biggest wind turbine manufacturer in China. China began to build wind farms starting in North China, where there's a strong wind and flat land. So it's easy to build wind farms. Under that condition, a cost-green design with all wind turbines share same design was acceptable. With wind farm development moving to South China and offshore recently, personalized wind turbine design is required so as to guarantee the wind farm return on investment with weaker wind and more sophisticated geographical conditions. Personalized design led to dramatic increase of design workload. For mid-size wind farm of about 50 wind turbines, if the farm owner wants 20 different plans to choose according to its ROI consideration, then the design workload is about 1,000 times bigger than one plan with one design. Adding more wind turbine designers cannot address the challenge. So new technology is required to reform the design process. We developed a data-driven distributed load simulation system and also an automatic post-simulation analytics system, which enables Gowind team to cope with the increased workload from personalized wind turbine design. Now let me talk a little bit about my company. K2Data is a startup company with mission to empower the industry transformation with big data and AI technology. We target to be the most trusted big data and AI technology partner of industry companies in China. K2Data has a team of data scientists who love to step into the factories to understand customer problems and develop algorithms and solutions in the field. The team once won first place of Prognostics and Health Management Society Data Challenge in 2017. This is the first time a team from China won the first place in the history of this famous annual event for industry data mining. K2Data is among the pioneers of industry big data service in China and has served many leading industry companies including China State Grid, PetroChina, Goldwind, Steel. It received top 10 Big Data Products and Solutions Award by the Ministry of Industrial and Information Technology in both the year 2018 and 2019. Earlier this year, K2Data was named by World Economic Forum as a technology pioneer, together with other four companies from US, Israel, and Germany in the area of advanced manufacturing and products. In order to accelerate technology breakthrough and field development, K2Data also established a joint R&D effort named IBD, Institute for Industry Big Data, with over 20 leading industry companies, industrial research institutes, and also universities in three cities, one in Beijing where the universities and talents are. Another two are both manufacturing centers, so we can serve market needs closely. Here are major industries served by K2Data. Most of them already have good foundation in automation and information, so it's timing for digital transformation for them now. The conference organizer also suggests me to share some of my personal experiences during my speech, such as how to balance work and life, but I do not think I do a very good job in that. So rather, I like to share some lessons I learned in running a startup. Before I found K2Data, I was a researcher working for IBM. It said that time is coming for researchers to found companies. This is a picture shared by Mr. Qi Lu, who used to be a senior vice president of Microsoft and Baidu, and later on founder of Miracle Plus, which is a tech incubator and investor. The original picture is from foundersandfounders.com, illustrating the history of opportunities, highlighting the best value creator role in different times of history, from hunter in ancient times to oil drillers during early 20th century, financiers in recent decades, and now startup founders. He ended his personal opinion that researchers may become the best value creator next. I personally agree with him, especially I was a researcher, so I am willing to believe this is true. But I also found that there are disadvantages for researchers to become a successful entrepreneur. Due to the training and practices as a researcher for many years, we tend to focus on a specific technology area working on solutions. What I learned after making many mistakes in running my company is that we should care more about the problem, people behind the problem, and also develop plural thinking capabilities. First, we should care more about problem over solution. Although K2Data is a technology company, we found technology is not the most important successful factor. There are three more important success factors before technology. First is to find the right application scenario with a true problem someone wants to pay to solve. Then there are many domain knowledge we should understand associated with the application scenario. We need to understand aerodynamics when work on wind turbines, mechanical engineering when work on engineering machinery, metallurgy when working with steel manufacturers. Another key success factor is data. Can we get sufficient data both in quantity and quality to solve the problem? We found that sometimes 80% of the time is spent on getting data and also clean the data. Another very important lesson learned is to have empathy with people. A good technology solution should come with good user experience, which can naturally fit into the daily work processes of the users and fit usage habits and skill level of the user. Methodology and tools such as design thinking is very helpful in establish user empathy and design a solution with good user experience. It's a common practice in my company that we run joint design sprint with end users, so we can bring the experiences and also the thinking from the end user into the design. I also found plural thinking is essential. Given the area I'm working on as an example, industrial big data and AI is not a single technology domain. It actually involves multiple different technology domains of operational, digital, and information technology. And I found that people from different backgrounds have quite different thinking logic, and sometimes they can hardly understand each other and can hardly work together smoothly. For instance, people with mathematics background tend to look at the study object as a black box and observe it from outside by analyzing data connected, while people with backgrounds such as mechanics, electronic engineering will first tear the object into parts and try to understand the working mechanisms of each part. Actually, what we should do is to learn from different domains and to combine different thinking styles together to build a plural thinking capability. If we want to build a digital twin for a given physical system, we should take into consideration both its working mechanisms and also rules mining from data, as not all working mechanisms of the physical world are known by people. The last but most important lesson learned is do have support from your family if you decide to run a startup. It will consume most of your time and energy, so have your family, especially your husband's understanding and support is very critical. Here, I like to express my gratitude to my husband for his support, and I also wish that all women working in technology have their family support so as to pursue further in career. Thank you for listening.